Right. I haven't really prepared anything, so feel free to ask questions. I guess I'm happy to go over just like the topics that we will go over. I'm happy to do that, or we take questions directly. But let me so I said that the exam covers chapter 5 through 8. Okay, so that covers the normal model, and in normal model you have two kinds that we talked about. The one parameter model and then the two parameter model. Okay, and the two parameter model we did back in chapter 5 is the semi-conjugate that you're gonna have posterior derived for both. Okay, and then in chapter 6 we move to give sampler. Okay, that's where you put independent priors for both the mean and variance when you're doing the normal. Okay, but at that time you won't be able to derive posterior distribution for both of them, but instead you can get full conditional, which is if you have theta 1, theta 2, theta 3. This is very generic, just 3 parameters in the model. If you can derive theta 1 given theta 2, theta 3, and the data, you can also do theta 2 given theta 1, theta 3, and the data, and also theta 3 given 1, 2, and y. If you can get all of this, each of this is a full conditional distribution. And if you can get all of this, you can run a Gibbs sampler for your inference. Okay, so that's for mostly chapter 6. But chapter 6 over there, I think the example that we went were mostly still about the normal model. Okay, but now with JAX, you can actually expand to all kinds of other model if you want. Okay. And then we talked about hierarchical modeling first, which is chapter 8. So that, again, everything was under the normal assumption using the normal model. But like what we did in the, in the case study about the Italy marriage rates example, you see that for counts, you might want to do Poisson and gamma. And over there, if it makes sense to your hierarchical model, you should do that over there. So that was the extension of the hierarchical model that we have done. But in class, when we're doing the normal case, we didn't derive it. We just read off like the parameters based on what we know before. So for derivation, I wouldn't request that kind of derivation. Okay. And then last we talk about chapter 7, which is the multivariate normal. And that is when you have multiple responses for one observation, and you believe that they jointly follow a multivariate normal distribution. So over there you have multivariate normal for the mean as the parameter, and then Wishart or inverse Wishart, depends on whether you're working with the precision matrix or the covariance matrix. And over there, we didn't derive all of them, even though I show you the results. And then you should know how to say, if you're given all of those full conditionals, you should be able to code it up by yourself. Or if you want to use JAX for your inference, that's welcome as well. Okay. Yeah, and of course, I guess in the Gibbs sampler in chapter 6, we also talk about this mixture model. Okay, once you have two components. So we talked about that in the MC diagnostics, but also in one homework question, which was probably one of the most demanding ones, which is question 6.2, when you're dealing with a normal response. When you plot it before you do any kind of inference, it looks like there are two modes. So that will be an indicator of you might want to do a mixture of two, which means you're gonna have like normal, say like normal mu1, sigma 1 squared, and normal mu2, sigma 2 squared. And what's important is you're going to have the weights in front of them. So if you have two components, it's going to be P and 1 minus P. Okay. So in the setup that we did in class, like in the homework, this is you're going to put beta prior for them because P is a probability between 0 and 1. And then you just have your regular inference for the normal as before. Okay. Yes.
In that setup for 6.2, it asked us when we were running our div sampler to each round take the higher draw of the mean between the two thetas that we drew and make that theta 2 and then the lower value to make it theta 1. Are people remembering this? Yeah. So I don't feel like I quite understand why that's mathematically justified, given that I understand that theta 1 is supposed to, or theta 2 is supposed to have a higher mean than theta 1, but given that we drew a theta 1 and a theta 2 from their respective full conditionals, why are we allowed to just switch them in our div sampler? And I guess more importantly, why is that actually what we want to do?
Mm-hmm. Okay, so let me try to rephrase the question. So that's, if you have your textbook, you might want to open to that page. For those of you who might not remember what we're talking about, so it's 6.2, which is the mixture model. And right, so it's pretty much part C, okay? So when you do, okay, yeah, so we were doing this setup over here. Okay, yeah, so obviously, like in the setup, we have a separate normal for the first component, a separate normal for the second component, and each of the mu, sigma 1 square, and mu 2, sigma 2 square, they all have their own own prior distribution and then full conditionals, et cetera, et cetera. So if you read C carefully, like instead of just try to do it, but think hard, it's actually asking you to have theta 1s to be the minimum of this theta 1 and mu 1, mu 2. Sorry, like the notation. In the textbook, they're using theta, but here I'm using mu, but it's talking about the mean. So pretty much, Eli's question is, they actually ask you to track the minimum and the maximum between these two and save them separately, and then do, I guess, autocorrelation functions or any kind of like effective sample sizes or any kind of other MCMC diagnostics. So why you should do that and why it makes sense. So this is actually a great question. And for any kind of mixture model, if you just think through, say in this case, we have two components only. Okay, so every time you only assume that it comes from two. So like each observation is gonna be either 1 or 2 for both cases. But of course you might have more. So once you have multiple components, so that's why in any kind of mixture model, there's problem or like a technical issue underneath that people should take care of is called the label switching problem. So if you think about, I have the first one, this is my first component, right? First normal. This is my second normal, okay? If I run through my MCMC, how am I supposed to know that they won't switch at some point? Okay, so pretty much, this is actually an issue with mixture model most of the time as well, is that because every time you allow, so the first normal is coming from its own full conditional, the second normal comes from its own full conditional, and every time, like every iteration, maybe you're gonna have two distinct normals anyway, and you keep having like the first one is having the higher mean, the second one is having the lower mean, but sometimes things might switch. You never know, right? So in any kind of, so this is only two mixture components. If you have more, it's gonna be even worse. So one way people keep doing is actually what part C is doing, is trying to ask you to keep like the larger one aside, like in one part, and keep the smaller one in another, and just keep track doing all of this to make sure that, well, every time my first component is that component that's having the higher mean. And every time my second component is the one that is having the lower mean. So ideally, eventually, they will be more distinct in some sense, because otherwise things would just be lumped together across the chain. Okay, so that's my answer at the moment. I need to go back to figure out like whether mathematically this is, I'm sure, I think there must be some justification. I just don't know at the moment. But pretty much, I would say this is the problem that we're trying to tackle. Okay, once you have multiple components, which one going to be consistent? I want to have, say, 2, so I need to have 2 separate. So one way to do it, since we're talking about the mean draws, so it makes sense to have these 2 separate. One is always the higher one. The other one is always the smaller one. And you keep them separate. Yeah. Yes. Sure.
We're deriving the functionals, I think it's the xi's, and you use Bayes' rule and you get like each one. I didn't understand how once you got those 2 different like things, how that made it a binomial.
Okay, great question. So Serena's question is, once, okay, still about this mixture example over here. I probably have the solution with me, so give me a second. I just want to get it right so I don't say things wrong. But so if you derive, so in the solutions that provided, if you look at the full conditional for xi, which is going to be the label, okay, would be the indicator for whether it's going to be the first component or the second component for each observation. You will see that, okay, so xi, so let's see, it's going to be 1 or 2. Okay, okay, so if the full conditional of this, we show it, going to be p times d norm. Let me write it out so it's easier for you to see. It's going to be a binomial. And similarly, it's either going to be 1 or 2, right? So the other one will be p norm, p times d norm, and then theta 2, sigma 2 squared, and the sum will be the same as before. Okay, so this one, when we try to come up with the probability, we're using Bayes' rule, okay? So on the top, you're evaluating your, so for xi, the data is yi, right? The data is yi for both cases. So you're trying to evaluate the density of this yi, evaluate at the first component, multiplies with this weights, that's on the top, right? If you're looking at one of them. And then in the bottom is the sum of these 2. The first one will be from the first component. The second one will be from the second component. Okay? So if you look at this sum of these 2 equals to 1, right? So if I define, say, the first one to be a success in terms of when I'm drawing my Gibbs sampler, this will be a multinomial draw, okay? And in particular, it's a multinomial draw with sample size 1, because I only draw 1 of them, so n is 1, while the success probability will be, say, in the setup that I did, it's gonna be xi equals to 1. Yeah, so a natural question to ask will be, what if I actually in the MC diagnostics slides, or like the lecture, we were looking at 3 components, if you remember. We're looking at 3 normal. So we're saying you have normal -3, I forgot, maybe 1, and then normal 0, 1, and then also normal 3, 1, right? We are having 3 components over here, and the probability that we know for the truth is 45% from the first component, 10% from the middle one, and 45% from the third one, okay? So once you have more components, say 3 components over here, when we say components, it's one component from a mixture, okay? And each of this will be a component over here. So if you do that, you'll realize that it's still gonna be, oh, it's not, sorry. Yeah, so over here, it is a binomial because you only have two outcomes, right? Two possible components. If you're gonna do more, you're gonna be a multinomial, okay? And each of the probability will be like a ratio like this. On the top will be coming from this component. In the bottom, in this 3-component case, gonna be sum of 3 different probabilities. Yeah, so this will be the setup. Okay. Yeah.
Should be P minus 1 for the xi equals 2 on top?
Oh, yes.
Or
Yes.
1 minus P.
No, you're right. Yeah, thank you. Right, it should be 1 minus P over here. Okay, because P is defined to be the success. I mean, in the model, it's going to be not the success. Sorry, the probability that it's going to be coming from the first component. So for the second one, it will always be 1 minus P. Yeah. So this is right. Each of this is a Bayes rule. And the rest of that, I think, is hard work of derivation. But you can tell, especially once you come to the outcome, you'll realize that a lot of the parameters can be read off based on which, say, if you remember the question roughly, you will know that for the first component, mu1 and sigma 1 squared, in order to come up with the full conditional for this mu1, you only need to have all of the yi's that is from the first component when you're updating it. Okay, so that kind of idea, you should know that that's what we mean by you can easily read it off. Okay. Sure. Yeah. So say for the normal, the first component. Yeah, in the homework, I asked you to derive it, right? But eventually, once you derive it, you'll realize that, say, this mean is gonna be like the full conditional, gonna be a normal, but the forms are very similar to before, like what the semi-conjugate prior that we have seen before. But now all of the updates that you need to use. So for example, back then, the mean is going to be the weighted average of the prior mean and the sample mean, right? I mean, before doing any kind of mixture, right? But now if you're doing mixture, you know that the mean will still be the prior mean, the weighted average of the prior mean and sample mean, but now the sample is not the entire sample. It's only the sample that falls into the first component. So if you look at the solutions that I posted, that particular normal, say the weighted average for the mean and the weighted average for the precision, it's only going to take into account those ones that's being clustered or like that's being recognized in the first component. Make sense? Mm-hmm. Anything else?
Can you go over like what we're expecting to know for the multivariate models?
Okay, so multivariate, let's see. I can bring the slides so I can show you. Oh, yeah. Yeah, so for multinomial, when we talked about it, so first of all, you should know how the likelihood is if you have a multivariate normal. So this will be the likelihood in terms of precision matrix, and this will be the likelihood in terms of the covariance matrix, okay? And then what we talked about is, so that's just likelihood. And then with the likelihood, you know how you can set up, set up priors. And then in this case, you have two priors. One is on on the mu, which is the mean vector. Okay, that's going to be another multivariate normal. So here I didn't include the density, but you should know it would just be the multivariate normal density that you should know. And then the other one is the semi-conjugate prior for phi, which is the Wisher distribution. And if it's gonna, I mean, first of all, it's open book, open notes, so you can bring all you need. But like for multivariate normal, if a question gonna appear, I would tell you like the likelihood as well. Like I will give you all of the density, so you don't need to like memorize all of them. Give me a second. Yeah. And then so you with the Wisher prior and the normal prior that you have, we talked about the full conditionals. Okay, so I didn't ask you to derive it. I pretty much only asked you, so that's not expected. I pretty much only asked you to understand how this is a weighted average of the sample and the prior. That's pretty much it. Yeah. So in terms of like derivation, et cetera, this will be, if it's gonna happen like appear in the exam, I will give you all of the detail, but you should understand what they are. Yeah. And then of course, in terms of data analysis, we have code, et cetera, online on Moodle. So you can utilize those to do your, if it's gonna happen in the take home, that would be what you can go for. Okay, give me a second. So that Eli first.
Yeah, so the quick question I had is the book the chapter about missing data.
Don't worry about that one. Yeah, so that's 7.5. Don't worry about that one. Yeah.
Just another question. Back as can I bring all problem solutions?
Oh yeah, of course. It's open book, open notes. So anything you want, that's totally fine. And I know some of you do not have a hard copy of the textbook, so I have a copy. The math office has one, so we at least have 2 for you to borrow. But if it's gonna be more than 2, we just have to like shift it around, do an exam in some way. Yeah. So just try. So who would need a textbook, like a hard copy? 3 of you? You can, but I don't want to waste your. But up to you, of course. Yeah. I just don't want people to use laptop during the exam. Yeah. But the solutions I have is we're gonna have 2 copies available. So if you're gonna print or you're gonna. Okay. Anyway, so all 3 of you will try to just sit close to each other in case. Yeah. But no. But I will see. Paul, do you happen to have a textbook? You don't either. Okay. Yeah, but you're taking it separately. Because I was wondering if you have a copy, we can borrow yours tonight. But if you don't, okay. Yeah, I think. Let's see. I have a copy. Do you happen to know any other students who took it before who have a copy? Yeah. Well. Yeah. So I mean, I will be around just to like in case if you 3. Oh yeah. Okay, I will ask Bayan for his copy. Hopefully he has one. And then good catch. Yeah. Right, I will ask him. And I mean, worst case is gonna be 2 text copies shared among 3, but we'll figure out something. Yeah, but I know because you all have like limited money for printing. I don't want. Everything is also a waste of paper as well. Yeah, and so so I don't. Yeah, but right. I will ask Bayan after class, and then if he responds and he has one, if you 3 don't hear from me at all, just come without any printing.
Okay, so we don't hear from you, assume that we're.
Yeah, I will figure out. Yeah, there's a chance I will forget, but probably. Yeah, just come. Yeah, okay. So if you don't hear, just give me a second. Let me email Bayan now, so I don't forget. Yeah, and but sorry, just give me a second. I'll just email Bayan. I might know some. I don't remember who else. Okay, yeah, so if you don't hear back from, yeah, okay. Okay, anything else? It's still there. No, it's still there. Okay, I think we're good. Anything else? Oh, yeah, I also have homework to return, but in the meantime, because we still people recording things, I just want to make sure that we have material for whoever will watch it. And anything else? Yes. Yeah, if right, I should say it will be asked you, like it will be asking you. So at least the question if hierarchical model is being tested, are you would you be asked about drawing like a graphical representation? Like I will specifically ask you for that. So if it's not asking, do not like if you want, I'll try to like feel free to offer. But I mean, I will ask specifically if you need to do a hierarchical representation. Oh, I can do many other things, right? So yeah, so hierarchical, I mean, I should say, so for example, like when we're doing the gamma Vassar hierarchical model, I wouldn't ask you to derive things, of course. I mean, that was not expected. And even in the textbook, when we're doing the normal example with the hierarchical, we pretty much just show like that will be the full conditional, but we didn't derive them either. So that kind of derivation is not expected. Yeah. Mm-hmm. Yeah. Right. But I think more importantly for you is to understand why we should do hierarchical model, and then what are the parameters that we're putting the hierarchy on, right? And that will be more, I think that was the biggest takeaway, I think, from the class. And say if it's going to be the take home, then I have more flexibility to test, of course, in terms of like doing analysis. If it's going to appear in the exam, then more about saying maybe I'll ask for a graphical representation, maybe I'll ask for like whether you should do this, whether you shouldn't do this, etc., etc. So ideas about those, I think, are more important. Yeah.
So when you derive a full conditional using the JAGs and not in a hierarchical situation, would you do it the same way but just not have 2 for loops? So just 1 for loop instead of, because we had 2 for loops and 1.
Oh, you're saying that if you have the full conditionals in the hierarchical model and you don't use JAGs, you use a regular.
No, I want to use JAGs, but you said you can use JAGs just to derive a full conditional.
Oh, no, I didn't. Sorry, did I say?
I thought I wrote it down.
Oh, no, sorry,
I
okay.
could be wrong.
Right,
But
full conditional itself, I mean, it depends. So, okay, full conditional is, let me see. Of course, it depends on what kind of model that you're doing, but at the beginning, I wrote it down pretty generically, saying that if you have a model that you have 3 parameters, then, and then, of course, the data model itself, then full conditional is, for theta 1 is theta 1 given everything else, theta 2 given everything else, and theta 3 given everything else. Okay, so I was saying each of this is a full conditional, okay? And in terms of implementing a model, I was saying that if each of this is a full conditional and you can recognize them, then you can use a give sampler, okay? And give sampler, you can either code it yourself or use JAGs. That's what I mean.
So like this is in hierarchical, but.
Oh yeah, right, it's gonna be the same. Right. Yeah, so yeah, in hierarchical, say if you look at the textbook and also in our slides, we did show what the model, like the hierarchical model would be, right? At the, say like the higher level, that's like at the data model, that's what the data is. And then once you're gonna put a hierarchy in terms of the mean, you're gonna have a bunch of mean, like mu1 until mu j follows another normal. So you can think of that as another layer of the prior. So you are still able to derive all of the full conditional if I ask you to do it. Okay. So what was it? The hierarchical model that we dealt with in class is this. Right? So this is the data model that the person, like the person I in school J, the score gonna be a normally distributed random variable centered at the school mean and a sigma square, right? And then the hierarchical model was mu J given mu and tau square, gonna be mu and tau square, right? And then lastly, I think for sigma square, we put a inverse gamma. I forgot the parameters, but let me use A and B for now, okay? So this, if say, like this is a hierarchical model. We didn't derive it in class, but if you were to derive it, you can still get all of the full conditional. And what I was trying to say is, this is hierarchical, but no matter whether it's hierarchical or not, you pretty much only need to focus how the model is set up and then how the priors are specified. And once you know that, no matter whether it's hierarchical or not, you should be able to derive the full conditional. It's just in class, I didn't expect or I didn't require you to do all of those. But if you were to do it, and the textbook actually shows you, you will be able to do it. So in exam, for example, so that's why I was saying if you look at midterm 1, like that would be the indicator, say, the difficulty level of what the derivation you expect to do. Okay, if I give you the likelihood or like the data model, you should be able to write the likelihood. If I give you the prior in various ways, you should be able to write the joint prior. And then you should be able to multiply them together to get the joint posterior and then do the full conditional one by one. Yeah. Yes, sir.
What if you wanted to, like, for this example, to it, like, the mu j's weren't, like, mu j's, like, it was like they were just like sigma, so it's like not hierarchical. That's what I'm at. Yeah. So, like, and you wanted to use JAGs to do, like, it was like y and use square, and then you.
Oh. I thought you just, sorry. Okay, so I guess you were saying, sorry, Rachel. I guess you're saying mu j given sigma, is that right? Not hierarchical? Yeah. So, okay, so in this case, I mean, the model was set up in a hierarchical way, but if you remember, the simplest model that we ever did with the normal was this, right? Like IID over here, and then mu, let's see. For the semi-con, so we did multiple versions, right? So one version of it will be like the semi-conjugate. That was doing mu given sigma squared is the normal, and then sigma squared itself is the inverse gamma, right? So back then, for the semi-conjugate in particular, you can, so these are the priors, and once you do all of the calculation, you can get the posterior. Let's see. Yes, in this case, it's the posterior, I think. Right, so if you can get all of the posterior, not the full conditional, but the posterior, then you can use JAX, I guess, but it's probably, you don't even need to use Gibbs. You just need to use multi-color approximation because you know the full conditional, because you know the posterior directly. Yeah, but if you're gonna use, say, another situation that we did before is independent priors, that's when mu is some normal and sigma is some inverse gamma. So those are the cases that you do not get posterior, but you get full conditional. And yeah, I'm sure JAX can do it. So I just, like, back then I didn't want to introduce JAX because we don't really need it at that moment. So I didn't introduce, but I'm sure this model say like, okay, so I would imagine in JAX, you first of all specify the data model, right? Just like what we did before, like using the first line. And the second one is very straightforward. Just tell JAX what mu is and what sigma square is, and it's gonna do it for you. Yeah, because in JAX, as you can see that you don't need to derive anything. You only need to know the likelihood, like the data model, and you need to know the prior, and then JAX gonna pick whatever algorithm for you to run it. Yeah. So I never did it myself. I'm just saying that for a data model like this, and then for the independent priors like this, I would imagine very straightforward to implement using JAX. Yeah. Yes, Nick?
Only cases where group variances are the same for normal hierarchy.
I mean, that was what we covered in class, right? So, so derivation-wise, I wouldn't require for either anyway. Yeah. So, right. So if it's the return exam, I think the biggest takeaway for the hierarchical model is how to set it up, and then and say like if I tell you what the full conditional is, you can describe how you're gonna sample it, et cetera, that kind of questions.
Unless because if the rest are not the same, then the priors for the parameters, one of them is
Right. So yeah. So I was saying okay. So I wouldn't require that because we didn't cover it. And obviously, I think when we're trying to implement 8.5 with JAX, there are some issues here and there. So I wouldn't, I mean, not issues, I said there are different ways to do it. And we were not able to fully replicate what the textbook was showing. So at least I wouldn't require that, at least in the return exam, I should say, because it's be too much to derive. But I was saying for hierarchical model, I think you need to understand how to set it up and why you chose that, and right, and then maybe I will give you the full conditional distribution and you can describe to me how you're going to sample things. Yeah, things like that. Yeah. Mm-hmm.
Can we go over what the difference is between an informative and a non-informative prior?
Mm-hmm. I guess it's probably easier to go to a particular context. Do we read this in the normal? Mm-hmm.
Uninformative prior.
Okay. So right. So that one. Okay. So again, actually, in terms of priors, people have different names for different priors. So I wouldn't worry too much about the name. Say if it's gonna be in the exam, you would just take whatever the prior is given to you, and or for example, the differences between these two especially I think in terms of applications, it's going to be normal. Give me a second to find the context to talk about it. We're talking about point. Mm. 78, there's the upper is up, okay? I don't care, but I'm not. Yeah, I mean, okay. I don't know if I will have time to go back and then summarize anything to send an email about this exam, but pretty much, I would say if it's the written exam, then you will pretty much be given what the prior is, so just go with that for the derivation. But I think in terms of applications, people sometimes, and also depends on the model itself, people will try to put different types of priors. So informative, non-informative, and weak priors. Weak priors. All kinds of different priors over there. I would say because we didn't spend time to talk about any of the choices over there anyway. So for me, a lot of times, if you look at the example that we have gone through, say like the multivariate normal case, like how you're gonna set up the prior for so the data was a normal, multivariate normal with mu, which is P as well, P dimension, and then covariance matrix. When we did that, we talked about how to set up, like choose priors for both of this, right? So I think for me, a lot of times, I wouldn't worry too much about the names of the prior, but mostly about what kind of priors I want to put, like to reflect, say, my beliefs, right? So, and then of course, when you're talking about this, so for both mu and sigma, so for the mu, both of this will be, they have a prior sample size, which is one of the hyperparameters. Say those ones will be how confident you are when you're choosing it. So I think that's the biggest, that's the most important thing to understand from all of those examples. Yeah, because my own experience with like so far with the prior names is they just have so many different kinds, and then it's not clear like why you should use one over the other in some cases. And I think a lot of times it's very specific to the model. Say like if it's a normal model, they define it in this way, and then if you're doing another kind of model, so I tend not to pay too much attention of the names, but mostly how you will like to put up the prior based on some external information, some other knowledge that you have from other sources, and then you try to reflect those. Yeah. So for example, I remember for the multivariate bivariate normal for the mean in particular, because that's the score, right? Pre and post instruction. So if you're gonna believe that both, because it's the score, like the range is from 0 to 100. So you put both mean at 50-50, right? While for sigma, in order to I should say, like try to not like the scores to be too extreme, like less than 25 or higher than 75, then that would be how I'm trying to set up the prior for the variance over there. So I think those are more important for what we have done so far. Anything else?
Can I ask a question about the project?
Oh yeah, of course.
Just
Mhm.
is the only like content that we're providing the video and our slides?
Yeah.
So we should show like everything we've done on the slides.
Right, as much as you can. So my suggestion, let's see. Okay, so for the project, you notice that there are two things you're gonna submit. And I actually thought about like the video. I realized maybe instead of asking you to send me all of the videos one by one, maybe I would go back to check like if Moodle, like the discussion function, they probably like you probably will be when you reply or if you initialize a new discussion topic, you might be able to attach a video. If you can, then I will ask you just like to do it over there. Yeah, okay. All right, good. So okay, so two things you should submit: slides and a short video. Okay, so some of you asked it before, but maybe not everybody knows about the format for the project. Like presentation, it's not gonna be you standing here and talk about your project. It's like using slides. I asked for slides for about 20 pages, and eventually I will print each page on one piece of paper and then like just tape them on the board here and on the wall, so people can walk around to see other people's work. So what you're gonna do at the poster session that will be on that Monday, December the 4th, you just come in a little bit early so you can tape things on the board before this course starts. And we are having, I can help to tape yours, yeah, but, okay, okay, yeah, we can talk about that, but assume most of the people can come early. And we have, because they're group projects, so I think we have 13 projects in total. So what we're gonna do is we have 75 minutes. Now I have the first, let's see. So I break it into two, 7 and 6. So group one and group 2. Yeah, so group 1, there will be like 7 posters. I mean, there will be 13 posters around the wall, like around the classroom anyway. But for the first, I should say like 35 minutes, you will be whoever got assigned to group 1. You will be the ones who will be standing and talk about your stuff, while the group 2 people can walk around to see what other people have done. Okay, and then for the next 30 minutes, we're gonna switch. Okay, so I would give, I mean, it's all gonna be on one day, so that will be the format, yeah. And so the points of the video only just about 2 minutes. If you want to, yeah, if you have stuff like to show, like short slides or like things to write, that would be fine. If you don't, just talk about it as audio, that would be fine as well. I just want to get it up for you, for all of us, before the like poster session, so we know that what you have done, so we know something before we walk in. Yeah, because time is limited. We only have one 75 minutes class time for that. So in terms of, yeah, what you're gonna put on your, so video, I guess you can make the video the last, you know what you will be talking about. So for the slides, it's about 20 pages. I think people's projects range, yeah, like the topics and then the content range like vary a lot. So I would say it's 20 pages. If you're doing a paper, I think it would be nice to have, I guess, roughly about like 8 pages to summarize the paper. Like the key like I should say 8 pages of the methods. And then maybe another, I would say 6 to 8 pages of your results. Or any kind of replications. And then lastly, 2 to 3 pages for I would say like discussion and I guess limitation and future work if you were to do any. Yeah, so I would say, I mean, again, it might vary. So that's why I'm asking you to send it to me by that Thursday noon, so I can take a look. And just in case if anything needs to be updated, I will email you Thursday night to see if we need to meet on Friday, things like that. Yeah. So I'm happy to check like what you have put together. I think like because you know the best about your project, like which one you want to spend more time on, or like more slides on. I don't think I will have much I would say like ideas or any kind of, I might have comments based on how well I can understand based on the slides. Other than that, I think it's your own decision in terms of how much you want to do. But yes, it's gonna be the two things that you're gonna submit. So you have to decide what you're gonna do. Give me a second. Yeah. Sorry? Oh, it's also on Thursday. Yeah. So yeah, because last week I sent out the email, but I can remind you all again. So it's really quick. It's actually just next Thursday, if you realize how fast things are moving. But yeah, but I think many of you are pretty much on track of completing the project. Some of you may be a little bit behind, but on Wednesday, I think I have one meeting with 2 students about one project, but I'm still available during the class time on Wednesday if anyone else of you want to meet. Yeah, so right now I just have, I think, meeting with Nick and Eli at 1:30, but I'm free for that class time. I don't think we're gonna take the whole time anyway, so if any other of you would like to meet, just let me know. Yeah, but the Monday after, so 1 week from today, that Monday when we come back, the class time is used for doing project, but I would say at that time your project should be close to the final form because you only have like Monday, Tuesday, Wednesday. Wednesday we still have in-class discussion of the case studies, things like that. So don't forget to do it. And also, and then it's gonna be Thursday, and then that will be pretty much the due date for the project. So plan ahead. I know it's a lot of stuff, but try to, yeah, so for example, like the last homework, just 2 questions, is gonna be due after class ends. Yeah, so pretty much I think I try to pace it in a way that people can keep track. But of course, there might be some variability here and there. Just talk to me if you have concerns or suggestions. Yeah.
What are we supposed to say?
Oh, what do you think? What do you want to do? Yeah, you just have 2 minutes. Just let someone, like, just tell someone or tell people. Okay, I guess the assumption that we can all make is like it's just gonna be us mostly. So you're talking to people who know about Bayesian methods to the extent that we covered. Yeah, so if you want to assume, I mean, that's true for the slides as well. So depends, like, in terms of how deeper you want to go, and then how much more you want to talk about. And in terms of the video, I was thinking pretty much if you do an application, you might at least talk about say what the methods are, and then what are the what is the application and what's the key finding, just about in 2 minutes. Yeah, so think about, or maybe you can make it so attractive that people will come to see your like poster in that sense. So just tell someone what you have done, and then in an attractive way, I would put it that way, that people would be interested to come. Yeah. Mm-hmm. Yeah, like face matters, right? Now I'm saying that if you don't want to put any like slides or anything, I mean, Zoom, for example, if you have an iPad or any kind of like tablet, it's very easy to record and then show a whiteboard like this and then record the entire thing. So if you want, you can do that. But of course, if you just want to record the audio, that's fine as well. But like, as long as it's clear and it talks about what you will like it will be you are covering in your poster, I think that would be good enough. Mm-hmm. Yeah, so apparently I think Moodle discussion page, you can do that, just upload directly, right? So in that case, I won't ask you to send it to me, and so it's gonna be just on Moodle and then just to this group.
Or another discussion, you definitely make an assignment.
Okay, right. Okay, I will figure out. Yeah, I think at least I can check how I can do whether we can do it in the discussion format. Yeah. Mm-hmm. Anything else? So we have 2 more case studies, and that one, yeah, we're gonna talk about both of them on Wednesday after the break, and because we have done one so far, so pretty much every group is a group of 3 people. So the remaining 2 who didn't do any write-up before should split the remaining 2 case studies. Okay, so just plan ahead. I mean, both of them, I think, are pretty interesting applications of what we have done so far. So yeah, you should discuss early to decide who's going to do what. And all of those are reflected in the participation grade of the class.
So wait, this is just clarification. The
Yeah.
write-up is going to be more intense for the next 2?
No, it will be the same.
Kind of thing.
Oh, same kind. Yeah, pretty much the same. Yeah. Sorry, I just want I just want to make sure that it's a group of 3, and we're doing 3 case studies in total. So whoever, I mean, we need to make it fair in some way that not everybody, like not the same person is writing up every time. Yeah, that's all. Yeah, and you can do longer, you can do shorter, whichever you want to do. Yeah, that's fine. Right, so pretty much, yeah, the schedule for the remaining semester is tonight we're gonna have the exam, and then you have a week or a little bit under a week to complete the take home. I only give 2 questions on the take home. It's pretty much just to make sure that you know how to do R, how to do JAX to analyze the problem. The problem itself is not hard for sure. And but then in the meantime, you have your project to finish, or like to put in the shape as good as you can, and then the case studies that you need to take care of. And once that is done, you have about more than a week. Along the same time, like the last homework is due that Wednesday after the poster session. So we're gonna be done on the 6th. Yeah, and also I sent you the info about one of the undergraduate statistics class project competition, and for that I will look at the slides that you have been doing and the quality of work. And I will talk to you after the poster session, or like around that Tuesday or Wednesday to let you know if I think it will be good enough to be submitted. So we might need to just meet for a couple of more times to put things in a better shape, and then we'll be ready to go. Yeah. Last year we got a student won first place, which was pretty nice. And she was not doing something fancy at all, actually. She was just doing a hierarchical modeling of a particularly interesting data, and then she presented in a very I would say attractive way, like why she's interested in all of the problems, and she did all of the posterior predictive checks, etc., limitations of the study, etc., and somehow that I think was among like what the judges will evaluate. Yeah, so yeah, I think it will be something nice to be aimed at if your project is already at certain quality, and I'm thinking many of yours are at that quality, so it would be nice just to submit. Yeah. Okay, right, so I will still be in my office from 3 to 4 today to hold office hours. You can have more specific questions. And all right, so Wednesday, no class. If you want to just email me, we can set up an appointment. And but on Monday when we come back after the class, you should have your project to close to final